Back. Today the problem we'll be looking at is maximum subarray. The problem states that given an integer array nums, find a contiguous subarray containing at least one number, which has the largest sum, and return its sum. A subarray is a contiguous part of an array. Let's look at example 1. Given this array here, the output should be 6. Why? Because 4, -1, 2, and 1 contains the largest sum. For instance, if you take 1, -3, and 4, you would have 2 that's less than 6, therefore it's not the answer. Again, if you take 2, 1, -5, 4, you'll have 2, so it's not the answer as well. Example 2 only has one number, so the output is 1. Here, example 3, we have this array, and the maximum that we can get is just to add up the entire array. So let's go to the whiteboard and see how we can solve this problem. Given input array, we know that the output should be 6. One very obvious but not effective or efficient answer is to compute all the subarrays using 2 for loops and find the maximum value of a subarray. That would result in a time complexity of O of n squared, which is not what we want. Is there a better way to do this? Turns out there is. What we can do is we can have an array. We can have an array that is the copy of the input array. And what this array signifies is the maximum value at each index that we've seen so far, including the current element. Okay, that's a mouthful, so we'll elaborate what that means. What that means is at each index here, this array will get updated. So what the values at each index of this array should be is the maximum subarray value using only numbers including the current element from the past. So at index 3 here, this value here should be the maximum subarray value using the elements -2, 1, -3, and 4. But how can we solve this? We can do this using dynamic programming. So we will do this using dynamic programming from the left to right. And we'll start from the left. And we'll start here because what we want to do, we want to see if the value, if the element, we want to see if the previous element's value is positive or negative. If it's negative, we don't want to update the current element because that will only make the maximum subarray value more negative. So let's start at 1 here. We have 1 and the previous element is -2. Because it's negative, we don't update it. We move on to the next iteration. So now we're at -3. -3, and we see that the previous element is 1, which will make myself more positive. So I update this to -2. And I do this by adding the previous element to the current element. So now this is -2. And I get to the third index here. So 4, previous element is -2. -2 is negative, we move on. -1, previous element is 4. 4 is positive. We update as -1 plus 4 gives us 3. We get to 2. 2, previous element is 3. Update this to 5. Similarly for 1, update it to 6. And then -5, previous element is 6. Update it to 1. And then 4 plus 1 is 5. Once we have this array, this long array here, what we have to do is simply take the maximum. We simply take the maximum of this array, and it is 6, as you can see, which is the same as our output. To reiterate why this works, we create an array, or as you can see in the code, we can do it in place. We create an array, we start at index 1, we check if the previous element is positive or not. If it is not, we move on. If it is positive, we add it to our current element. We update our current element by adding the previous element to the current element. And each value in this array here signifies the maximum subarray we've seen so far, including the current element. And using this approach, we are only going from left to right, so it's a one pass. Hence, the complexity got reduced from O of n squared down to O of n. And because we do it in place, there's no extra space needed, so the space complexity is O of 1. Let's go to the code walkthrough and see how we can solve this in code. So we iterate through the nums array. So for I in range 1, and we start from 1 because we want to look at the previous element, and at index 0 there's no previous element. If the previous element is positive, so if nums I negative 1 is positive, then we update the current element by adding the previous element to it. And we do this in a for loop, and eventually, once that's done, we simply return the maximum of nums. And we're returning the maximum of nums because we have at each index here the maximum value of the subarray using only pass values. But we want the overall maximum. That's why we use max, which will get us the number 6. Let's see if this works. Oh, syntax error here for I in range. And then submit it. And it's a success. That's it for today. Thank you for listening, and see you next time.